Hey guys, welcome back to the channel. In the previous video, we discussed chain of thought prompting and saw how breaking a problem into intermediate reasoning steps can significantly improve performance on arithmetic, logical, and common sense reasoning tasks. However, chain of thought prompting still has an important limitation. It relies on a single reasoning path. If the model makes a mistake at any step, whether it's an arithmetic or a reasoning error, that mistake is carried all the way to the final answer. As we can see in this example, the model makes a simple arithmetic mistake early in the reasoning process. Even though the remaining steps are performed correctly, the final answer is still incorrect because the entire reasoning chain depends on that initial calculation. This led researchers to ask an important question. What if instead of relying on a single reasoning path, we generate multiple reasoning paths for the same problem and select the answer that appears most consistently across them? This idea gave rise to a powerful prompting technique known as self-consistency prompting, introduced in the following paper. In self-consistency problem prompting, the model solves the same problem multiple times using different reasoning paths and then selects the answer that receives the strongest agreement among those paths. So basically, this is how self-consistency prompting works. So we first use one-shot prompting and via chain of thought prompting, give it an example, and then we ask it to solve a question via its different approaches. So it gives a diverse set of reasoning paths, and then via majority voting, we select our final answer. So in this case, we took a top K sampling approach where our K was equal to 40 and temperature of zero point 0.5 or zero point 0.7. So you don't need to get worried with these terms. So basically any approach like chain of thought prompting follows 3D decoding, which basically means that we select the token with the highest probability. But here we are using top K sampling where K is 40. So basically we are considering the top 40 samples with the highest probability for our answer, and the temperature of zero point 0.5 or zero point 0.7 control the probability of randomness. So higher the probability, the more random are our answers. Generally probability of t equal to 2 or 3 are taken when we are doing a more creative tasks. So this approach of majority voting, where we are considering multiple paths, works because of an hypothesis these authors assumed in the paper. That is, even though correct reasoning processes are diverse, they tend to have a greater agreement in their final answer than the incorrect ones. This also led to error reduction, and majority selection helped in choosing the answer that most of the models landed on. So which basically means that even though we are trying different approaches, but there is high chance that most of them land on the correct answer rather than most of them landing on the incorrect ones. So this is basically the working of self-consistency prompting. So here is a basic difference between chain of thought and self-consistency. Where in chain of thought we have a question followed by a detailed reasoning path of step-by-step breakdown of each step followed by the answer it gets. And in self-consistency we have one question followed by 40 different approaches of solving that question and majority voting on just the final answer and then finally selecting the final answer based on these. So here are a few results which we can observe from the research paper. So there are three major things which you need to observe. Firstly, self-consistency beats chain of thought prompting in all of the cases which you could observe. Secondly, the larger the model is, the more beneficial it is, and the higher the gain is in case of self-consistency prompting. Thirdly, self-consistency prompting performed better when the task was more complex or the data sets were more challenging and difficult. So even self-consistency prompting is pretty good. It has a few limitations. Firstly, the computation cost is pretty high. Like you could observe that there are a lot of tokens being used in 40 different reasoning paths, then finally performing majority selection and then getting to a final answer. So the computational cost in this is very high. Secondly, this process is pretty long, like the entire pipeline. So we have to keep in mind that we can't use this for real-time applications where we require the response in a very rapid, like 1 or 2 seconds. As this pipeline is very long, it will take longer to respond. And thirdly, it's very complex as we have to apply a voting ranking procedure after getting all the answers. And also the thing we could observe is suppose two answers have a draw in the number of votes. Then in such cases of conflicts, how do we move forward? So I would highly recommend you once go through the paper of self-consistency prompting, and that is going to be it from my side about self-consistency prompting. So in this video, we learned why chain of thought prompting can still fail when a single reasoning path contains an error, and how self-consistency prompting addresses this problem by generating multiple reasoning paths and selecting the answer that appears most consistently across them. So that is going to be it my side from about this video. Hope you guys enjoyed it. Make sure to like, comment, and subscribe, and let me know how I could improve my videos further. Thank you guys.